I'm going to explain the nth roots method. And to keep it simple to start with, I'm just going to look at an nth root of 2. So basically just squared, which you could say, well, that's not very challenging at all. So in this case, what are we really trying to do? We're trying to find the square root of 9. Most common misconception that we've had, because we did Pythagoras' theorem in middle school, that we forget to add the plus minus. So we know that there's going to be two answers for z. That's going to be, oh, it's not letting me draw this very well. It's going to be plus or minus 3. There we go. So that was no big deal. Well, we could also do that same question by factorizing. From here we could go z squared minus 9 equals 0. The pen's playing up today. Must run out of ink. And we can factorize that into z minus 3z plus 3 equals 0, which implies using the null hypothesis law that z equals 3 or z equals minus 3, which we know is still the same answer as up here. Now, what's really the nth roots method talking about? Well, that's a little bit different, and like I said, you could argue what's the point in doing it on this question, but I'm trying to show you the links. So if we looked at it on an Argand diagram, then this 9 for z squared would actually come straight out. It would be straight out here. It's only a real part, and it would be 9 long. So that's okay. So how would that look? Well, we know that that has a magnitude of 9, and we know it has an angle of 0. Why is that? Well, because there's no turn clockwise, that would be positive, or anti-clockwise would be positive, or clockwise should be negative. So theta is 0. So in polar form, it would look like this. Z squared is equal to 9 cis 0. So we know that using one of our rules from polar form, that we know that that's the same as cis of 0, oops, sorry, that's 0, not theta there, plus 2 pi times k, so a multiple of 2 pi, which is a full circle back round again, would repeat it, and a full circle back round again would repeat it, both in a positive or negative direction. Well, that will simplify down a little bit to 9 cis, and you may prefer to write the k first, so difference, k 2 pi. How does that help us? Well, then we can bring the z over, which we know is going to be square root, which is the same as saying to the power of a half. And again, De Moivre's theorem said that this half can come inside, become a power of the 9, and also a multiplier with the cis part. So that would become 3 and cis k 2 pi all over 2, which we know will simplify slightly to 3 cis k pi. Alright, so how does that help us? Well, when we use the nth roots method, our k starts at 0 and then becomes 1, etc., all the way up to n minus 1, and that will be, because that will then give us all the roots. So in this case, because n is 2, then it would just be 0 and 1. So if we then put that in there, we're going to get 3 cis of 0 pi, and we're also going to get 3 cis of 1 pi. And we know from that information that cis of 0 pi, well, that actually gives us just 1, so that would be the same as saying 3 times 1. And we know that cis of pi is minus 1, so that will be 3 times minus 1 as our other answer. And that will equal 3 and minus 3 as before. So exactly the same answers repeated all 3 ways. And there's a simple example of using it just with z squared, but you could use z cubed, z to the 4. In fact, any root at all. Thanks for watching.